recording. Okay, perfect. All right. So for this, guys, for the warm-up, it wanted you to simplify this expression. So what I see here is I've got this expression in parentheses, and it's raised to the negative 1/3. So I'm going to distribute that negative 1/3 power to each one of these expressions. So I'm going to get a to the, and that's going to give me 1/2. Let me erase that. That's going to give me 1/2. And then b, if I distribute that, that's going to give me negative 1/9. And then for a, if I distribute that, I'm going to get 1/2. And then for b, I'm going to get a positive 1/3. All right, and then over, then that'll be a to the 2/3. Okay? All right, so that's the first step, is to distribute your things. Yeah, now I'm going to add. Yeah, that's right. I'm going to add. That's good. I'm going to add my exponents. So let me circle. I'm going to change colors to red. So I'm going to have 1/2 plus 1/2. So that's going to give me a to the first. And then I'm going to have negative 1/9 plus 1/3. That's going to give me a positive 2/9, hopefully, is what your calculator gives you. All right? But you're not done. You still need to move this up. So when you move it up, notice it's in positive 2/3. So when I move it up, it's going to be a negative 2/3. And so then that's going to be b to the 2/9. And then you can add these exponents, and you should get a to the 1/3, b to the 2/9. And that will be my answer for that one. And you could change it. You could have put b first and then a, but as long as you've got the right fractions with the right letters, you're good to go. Now, that was reviewing what we did for the past 2 days. So that's the past 2 days. Now, let's take a step back, and let's go back over the stuff that we did prior to fall break. That way you'll remember what you did on your test. So I've got about 7 examples that we're going to cover, one of each type, and then you've got your classwork after that. So here's my essential question, and your essential question is, a to the 1/3, b to the 2/9. All right, so your essential question for today is, what have we learned thus far? So these are some of the topics that we've covered. The first one was solving equations with rational exponents. The second one was converting radicals to rational forms. The third one was solving equations with radicals. And the fourth one was simplifying radicals. So these are the 4 types of questions we're going to look at, and I've got 7 questions total. So these are my main categories, not including what your warm-up was, guys. This is in addition to your warm-up. So go ahead and take a second and write down our first example, and it is right here. And then you don't have to classify this, guys, but this is an example of an equation that has a rational exponent. And remember, all a rational exponent is an exponent that's a fraction. So I'm going to circle it for you. So, guys, that's my rational exponent, 3/5. Now, notice that this is an equation. My equation for this is solving it for n. That's my variable, is n. I want to solve for n. And so this is negative 10 minus 5, open parentheses, 2 minus 15n to the 3/5 equals negative 50. All right, so I've got negative 10 minus 5, open parentheses, 2 minus 15n to the 3/5 is equal to negative 50. So I want to solve that for n, and so then I want to get this by itself. I circled the 3/5, that's my rational exponent. My variable is n. So the first thing I'm going to do to try to get this by itself is I'm going to add 10 to both sides. So I'm going to plus 10 to both sides, and then that's going to give me a negative 5, open parentheses, 2 minus 15n to the 3/5 is equal to a negative 40. So that's my first step. The next step, remember, you're trying to get this parentheses by itself. So we're going to divide by negative 5. So if I divide both sides by negative 5, then that's going to go out. So notice I didn't add 5 to both sides. I divided because that's multiplication. So then that's going to give me 2 minus 15n to the 3/5 is equal to 8. And see, now that you've got this expression by itself, you've got this exponent by itself, the way we get rid of a rational exponent is you do its reciprocal. So I'm going to reciprocate 5/3, but I'm going to do it to both sides. So I'm going to have 8 to the 5/3. So then when you do the reciprocal times a fraction, those cancel out to give you 1. They multiply to give you 1, so it's just like they're canceling out to give you 1. And so that leaves behind 2 minus 15n. Now, this is what you're going to type into the calculator. So you type in 8, then rooftop 5 divided by 3. And if you do that, you should get 32, if you did that correctly. So you just get 32 for that in the calculator. All right, I'm going to rewrite it up here so I can see it. So I've got 2 minus 15n is equal to 32. Now you can just solve this for n. So let's subtract 2 from both sides. That gives me negative 15n is equal to 30. And then for this one, then you're going to just divide by negative 15 to both sides, and that gives you n is equal to negative 2. But the key thing is make sure that you try to get that exponent by itself. Whatever you got to do, get it by itself. So make sure you get it by itself, and that's what you do for a problem like that. Get the rational exponent by itself. And notice that it had those parentheses, so you had to get those parentheses by itself. Don't distribute that exponent. Just when you're solving it, just try to go backwards. Try to get it by itself. So that's the first type of example. All right, the second type of example is whenever you had to convert. So case in point, take a look at this one. Seems pretty straightforward. It's in radical form right here, and it doesn't say right here, guys, but the directions for this would be to convert, and I want you to convert it into rational exponent form. So this is in radical form. I want it in rational exponent form. Well, here's how you convert it. Remember, this is my power, so it's a power of 4. This is my root. It's a root of 5. So the way you would write this is, make sure you put it in parentheses, put that 3x, and remember, the root goes in the denominator. So that would just simply be 3x to the 4 over 5. But the biggest mistake, guys, make sure you put that in parentheses, the 3x, because if you don't, let's say you put just this. The problem with this is if you don't have any parentheses, people might think only the x has a 4 over 5, and that would be wrong. It's the whole thing. It's all of that right there. It's all that 3x. So put that in parentheses. But straightforward, right? So that was going from radical to rational exponent form. But then we also did the backwards of that. So here's your third example. Let's say I give you a rational exponent, and I want you to go into radical form. So here's that example. So let's say you have this. And again, the directions aren't here, but I'll write them for you. So let's say this is a rational exponent, and let's say the directions say to convert, and it wants you to convert it into radical form. Well, again, I'm going to label it. Remember, the root is in the denominator. So there's my root. It's got a root of 3, and it's got a power of 7. And so then this is what's inside. That's what's being raised at, 6n. So here's what you have. You'd have 6n inside the radical. There's the 6n. Put the root. It's got a root of 3, so put a 3 right there for the root. And then, again, put those parentheses, and it's got a power of 7. So 6n goes inside the radical. It's got a root of 3, and then it's got a power of 7. And that would be your answer for that, just converting it from rational back into radical form. That's it. And so that was the second main topic that we learned. The third main topic was solving equations, but with radicals in it. So that's what we're going to look at now. I've got 3 examples of those. So here's your first one of those. So here's a radical equation. It looks like this. And so I've got negative 2 is equal to the square root of x minus 8 minus 4. Notice I said square root. So guys, the understood root right here, if you want to take a second and write it, if there's never a root right here, it's understood to be 2. That's called a square root. So if you want to put a 2 there, you can. But just like before, you're trying to solve this. In this case, you're trying to solve this for x. So you want to get the x by itself. So the first thing I would do to this problem is, I'd add 4 to both sides. And so that would give me negative 2 plus 4. That would give me 2. And that would be the square root of x minus 8. Now, the common mistake here, guys, is you would not add 8 first, because the 8 is inside of that radical. You got to get rid of the radical first. So the way you get rid of a square root is you square both sides. That's how you get rid of a square root. And so if you notice, the square and the square root cancel out, and that leaves me x minus 8. So I get the square root of x minus 8 squared. The square and the square root cancel out. That leaves me x minus 8. And then on the left-hand side, I'm going to just square that. So 2 squared, that gives me 4 over here on the left. And then I've almost got it. I just got to solve this for x. So I'm going to add 8 to both sides. So that gives me 12 is equal to x. And that will be my answer for that one. So just simply getting that variable by itself, squaring it to get rid of the square root. And that's how you would solve that type of problem. And that's a radical equation. Now, there were 3 types that we did for this. That was one of them. The second one is if you ever had a radical on both sides. And that's what we're going to look at next for the next example. So, for example, let's say you had this problem. Now don't let it kind of freak you out because you've got radicals on both sides. This is actually one of the easier problems. Because you have a radical on both sides, and these are both square roots, understood to be square roots, you can literally just square both sides, and you know that whenever you square a square root, those cancel out. And so what all you have is negative 2 minus 3x equals 3x plus 4. So it's really great that it just gets rid of those radicals. Now that only works if there's a radical on the left and a radical on the right. And so then those just go away. And then you can just solve this for x. Now I do notice I have an x on both sides, so I'm going to add 3x to both sides first, and that'll give me negative 2, that cancels out, equals 6x plus 4. And then just to solve this for x, I would subtract 4 to both sides, so that gives me negative 6 equals to 6x, and then that crosses out, and then divide by 6, so that gives me my answer, x is equal to negative 1. And so that's it. So just remember that, guys, on the test. If you have a radical on both sides, don't freak out. Just go ahead and cross them both out because they're going to cancel out when you square both sides. And so that's how you tackle an equation like that. So remember, there's 3 types of radicals. We did the first one. That was the second one. The last one that I'm saving for last, it was a little bit more involved. And so let me show you what that looks like. So here's the last type of radical equation. It looks pretty simple on the front, but watch what happens whenever we solve this. So notice it's the square root of negative 15 plus 8x. Notice that you have an x on both sides, so you want to solve it for x, but you can't do anything with this 8x right now because of that radical. So the first thing I would have to do to this problem, guys, is get rid of that radical by squaring both sides. And so then the square and the square root cancel out, and that leaves me negative 15 plus 8x is equal to x squared. Now, this is very important because this is not a linear equation. This is a quadratic because it's got a power of 2. It's got a quadratic, so it's a power of 2, which means that I will have 2 answers because it's a quadratic. So this is actually an easy one to solve. What we're going to do for this one, though, is we're going to move everything that's over here on the left-hand side over here to the right to make it equal to 0. So I'm going to add 15 and subtract 8x. So I'm going to get 0 equals x squared minus 8x plus 15. And so what I've done is I've taken this equation, I've moved everything over so it's equal to 0, and there's my quadratic. Now, it is true, I could use the quadratic formula on it, but if you notice, this is an easy trinomial. So what I'm going to do next is I'm going to factor this. So factors of 15, what multiplies give me 15? Well, I know 1 times 15 gives me 15, but I also know 5 times 3 gives me 15. Notice I'm trying to get a negative 8. Well, how can I get a negative 8? Negative 5 and negative 3. That's right. So I'd have 0 equals x minus 5 and x minus 3. Then I'm going to take each one of those and set each one of them equal to 0. And there's where my 2 answers come from. I get positive 5 and I get positive 3. So this one was the most involved out of all of them because it ended up being a quadratic, and so you had to either quadratic formula, which we didn't use, or just solve by factoring. And factoring worked out great for that one. All right, so of the last topic was what we covered before fall break was how do we simplify radicals. And we did one for a warm-up yesterday. So this is the last type of example that you're going to see. And then all of this, including what we did yesterday and the day before, will be on the test. The new stuff will be on the test. So we reviewed everything. All right, so here's your last type of example. So let's say I wanted you to simplify this radical, the cube root of 192xy to the 5th d to the 8th. Well, if you remember, we made a little chart to help us with problems like this. And so I'm just going to write it up here on the board so you can see it a little bit better. So like, for example, 2 squared is 4, 4 times 2 is 8, 8 times 2 is 16, 3 times 3 is 9, times 3 is 27, times 3 is 81, 4 times 4 is 16, 16 times 4 is 64, 64 times 4 is 256, and then 5 times 5 is 25, 25 times 5 is 125, and 125 times 5 is 625. Notice we're trying to get the cube root. So I'm going to look at this column, and I'm trying to find a number that's going to divide by 192. I'm thinking 64 will work. And so if I write that down, 64 times 3 gives me 192. And then let me change colors. The cube root of 64 is 4. So that means I'm going to have a 4 on the outside and a 3 on the inside. So that's where those numbers come from. And then now let's talk about my variables. Notice the understood power on this x is a 1. Well, 3 can't go into 1, so I'm going to leave that x inside. 3 goes into 5 one time. It leaves a remainder of 2. 3 goes into 8 2 times, and it leaves a remainder of 2. And so that will be my answer for that. 4y z squared, the cube root of 3x y second z.